We discuss the CHLP, right, students? Yes or no?
Yes, ma'am.
Yes, ma'am.
And so can you see my screen or what? Can you see my screen or no?
No, ma'am.
No, ma'am.
I didn't share the screen. Yeah. Okay, now I think you can see my screen, right?
Yes.
So we had seen the definition of the differential equation. Then we had seen definition of ordinary differential equation. Then we saw the definition of partial differential equation. Then after that, we have seen the order and degree of the differential equation, right? And then we saw some definitions of solution. And now we are going to see the different methods of solving the differential equation. Is that correct? Right? So what you can do is, have you made a notebook or what? Notebook or something to write? All of you?
Yes, ma'am.
Yes, ma'am.
Yeah, okay. So if you have made your notebook, then in that case, you can write the heading solution of the differential equations. And we are going to see the first method, which is called variable separable method. So guys, first you write down the heading, then we'll start. Okay, now see. Now, when we say variable separable, what is the meaning of this? We are going to separate the variables, then we are going to integrate, and then we are going to get the solution. See, remember one thing. Whenever we are saying solution, I told you that time in the definition what it means. It means integral only. Okay, remember, solution is the integral of that particular differential equation. So, for solving by this variable separable method, we need to separate the variables. So, here, for example, we have got x and y as the variables. Right now, they are mixed up, but we need to separate x on one side and y on one side. That means you need to get one equation which is of this type. Okay, so if you get this equation, then you will be able to integrate it separately and then find the solution of the given differential equation. So here we have got this dy by dx. It is e raised to 3x minus 2y plus x square into e raised to minus 2y. Now, who can suggest to me how to separate? Because it is very easy to do this. How you will be able to do this? Just suggest it to me. What
And
you
we
can do?
take e to the power 2y
Minus
in
2y.
that,
Yes.
and
You can take like
then
this.
take it with dy, and the rest part will be with dx.
Yes, that is correct. So what we can do, we can just shift this to the left hand side. Okay, club it with dy. And then all these terms, they are in x. So we can just club it with. So now this has become in the variable separable form. So once it has become in the variable separable form, simply we are going to integrate and report the solution. Now you all of you know integration of e raised to 2y. Okay, e raised to 2y divided by 2. Likewise, this side divided by 3 plus. And because this is indefinite integral, so you will add the constant of integration. So that's it. Now at this point of time, we have solved the differential equation. After this, if you wish to simplify, if you wish to report the equation in this form, by all means, you are free to do so. What you will have to do, you will have to cross multiply this 2 to the right hand side. So you will get this e raised to 2y. It will be this way. See, 2 by 3 raised to 3x plus 2 by 3 x cube, and 2c means that is a constant only. So I will still write it as c. Then what you will do, you will take log on both the sides. So you will get 2y equals to, then you have to take y equals to log of all that divided by 2. Are you getting the idea or what? Simplification part, students.
Yes, ma'am.
If you want, you can do like that. If you wish to report the answer in the form of y equals to fx, that means you will take log on both the sides. You will get 2y equals to log of all those terms, whatever are those terms. And after that, y equals to 1/2 log of all those terms, whatever are those terms. Idea is clear to you? So if you wish, you can do that. Otherwise, you can stop here and that's your solution. Okay, fine. So you can note this. Then we'll try to do one more sum. So whenever we are solving the sums on this thing, this solution of the differential equation, remember that the skill which you need to have, the most important skill is integration. So your integration should be very good. Then you will be able to solve such sums. Once you note down, just tell me, students, so I can then continue with the next sum. Noted or what? Done?
Yes, ma'am.
Yeah, okay. All right. Now see, now sometimes what it may happen that directly we may not be able to separate. Okay. So in that case, we will reduce to variable separable form and then we will solve the sum. Now to reduce to variable separable form, there are some types of substitutions which we can use. So the most standard substitution is this one, or it can be this way also. This way or this way. So if you are substituting y is equal to vx, then obviously you will find dy by dx, which will be v plus x dv by dx, and then you will proceed. If you are substituting this x is equal to vy, then obviously you are going to differentiate with respect to y. So in that case, what you will write? Y dv by dy. Like this way you will get the equation and then you will substitute. Okay, so this is the most common one, but sometimes we need to give it a thought on our own and then see what type of substitution we will make. So I will tell you that type of example also, where you will just think yourself what is the suitable substitution. Okay, so this problem directly it is not variable separable. So here we are going to do some steps and then after that we will do the substitution. So what I'll prefer to do is I'll take this 2xy to the right hand side and divide throughout by dx. Okay, so that it will be a little more convenient for us. And then we will make this substitution. So here you can see that this becomes equal to 2vx square and into bracket we will write v plus x dv by dx. Okay. And now we can do all these things. We can take x square common. So then we will write like this 2vx square into bracket v plus x dv by dx. Now you can just cut out this x square term, right? And then after that, you can multiply this 2v inside the bracket. And then we will take this 2v square to the LHS. So this will give us 1 minus v square is equal to 2vx dv by dx. Okay, now you tell me, can we separate this variable separable? Can we separate it?
Yes, ma'am.
Yes, we can easily separate it, right? What we have to do? Just
V dv upon 1 minus v square.
yeah, that's right. 2v dv upon 1 minus v square is equal to dx upon x. Now this is variable separable. So we have to just integrate this and get the answer. Okay, so this is a very, very easy integral. So I'll just, shall I rub this part? Students, shall I rub this much? These first two steps.
Yes, ma'am.
Yeah, so that I will just write the integral over here itself. Okay, 2v upon 1 minus v square. Very easy integral. Who will tell me the answer quickly? Yes. You might be knowing, no, integral f dash x upon fx, what it is. This part, no? Log of fx. So what you will get over here? Answer. Integration. So 1 minus v square derivative is minus 2v. So that is why we are going to have minus log of 1 minus v square over here. And this is equal to log x. Now please remember what I should write. Normally you can write c, but since all the terms are in terms of log, I will prefer to write this as log c. Okay, why I will prefer to write like that? Because I am going to remove the logarithm sign from both the sides and just report the answer like a equation. So what I can do is I can take log on one side. Okay, so I can take log on one side means I can write like this. Log x plus log 1 minus v square. Now please remember, minus log c means also that is a constant itself. So I can just keep it like this. If you want to write minus log c, by all means you can write it. And then remember that you will also do c raised to minus 1. In other words, 1 upon c. But overall, the log sign will go. So log of a plus log of b means log of ab. So log x into 1 minus v square, that is equal to log c. We will just write simply like this. And then after that, we can easily cancel out the log on both the sides. So what we will have, x into 1 minus v square is equal to c. Now we will resubstitute this value of v from here. V is equal to y by x. So how I will write this? X into bracket 1 minus y square by x square is equal to c. And that is our answer. If you wish to simplify further, by all means you can, but otherwise we have solved this equation. Do you have any doubts or any question? You can keep the solution as it is. Yes, that is right. Any doubts or any questions? Anybody wants to ask anything? By all means you can ask. Anyone? No? Comfortable? If anybody has any doubts, don't keep your doubts lingering, okay? Just ask me right away. Students, anybody? Division 6, division, yes, the CR of division 6, how many have you got any idea? How many are traveling? How many are this thing? DCR, how many? She's there.
Ma'am, actually, I don't know, but I will contact with CR and I'll let you know at the end of the lecture.
By evening, you just tell me, okay?
Yes, ma'am.
Yeah. All right. So now this sum, everybody has followed. Students of division 1 and 6, have you followed the method? How to substitute, huh? Okay, now I will show you one different type. There, that's what I'm telling you the point. Sometimes.
Ma'am, can you go back to the last slide, please?
Just 1 minute. Is it okay?
Yes, ma'am. Thank you. Yes, ma'am. Done.
Okay, fine. All right. Now, what I was telling you, that apart from these standard substitutions, sometimes we ourselves, we have to think which type of a substitution we can use. Okay, now let us say this is our problem. We have to solve this differential equation. So obviously it is not variable separable, so we have to reduce it. Now can you suggest to me what we should do?
X plus y equal to d.
Okay. See here, if you put y is equal to vx, okay, just for trial I'm writing like this. Suppose we put y equals to vx, what will happen? All that dy by dx and all that is fine, right? On the left hand side we will have v plus x dv by dx and is equal to, see how it will be, cos x plus vx plus 1. So the point is we are not separating. Here what is happening? That separation is not taking place. So this means that this is not a good substitution, right? So we have to think of something else. So now because this term is here in the bracket like this, what we will prefer to do is we will make a substitution for this whole thing. That means is plus 1 also we will include. Now if we do that, then we will get like this: 1 plus dy by dx is equal to dv by dx. Okay, and in other words, you can say that dy by dx is equal to dv by dx minus 1. Now what we can do, we can just substitute over here. So this will become dv by dx minus 1 is equal to cos v. And now you can easily write dv by dx is equal to 1 plus cos v. And this is, as you can see, that this is easily written in the variable separable form. So how you will write it? dv upon 1 plus cos v is equal to dx. And now we can try to integrate this. So 1 plus cos v, basic trigonometric identity. Who will tell me 1 plus cos v value? 1 plus cos 2v, you can think of 1 plus cos 2 theta. What is the 1 plus cos 2 theta value is 2 cos square theta. So using that same thing, this will be 2 cos square v by 2 is equal to dx. Now this is 1 upon cos square. So therefore I will just prefer to write this as 1/2 integration secant square v by 2 dv is equal to, this side will become x plus c. So what is the integration of secant square? Once again.
Tan v by
But tan v by 2, see, whenever we are doing the integration, supposing we are doing this, any integral value we are doing, we are always dividing it by the derivative of that function. Yes or no? Derivative of this value, right? No? So what should be your answer? 1/2
1/2
tan
tan v
v by 2 divided by what?
1
Derivative
by
of
2.
divided
1
by
by
1.
2.
2 tan x.
Divided
tan
by
v.
1 by 2 means multiplied by, no?
Yes. 2
So it is
tan
going
v.
to be like this. 2 tan v by 2 is equal to x plus c. Now 2 and 2 will get cancelled out. Now tan v by 2 means how much it is? Tan, how much? X plus y plus 1 divided by 2. Remember that is v by 2. So is equal to x plus c, and that is our answer. Now, if once again I tell you, if you wish to further simplify, it is totally up to you. At this point of time, we have got the answer to the problem. If anybody wishes, then they can proceed ahead, but as such, you can stop over here. Proceed ahead means how you will take this side, you can transfer x plus y plus 1 divided by 2 is equal to tan inverse of x plus c. Then you are having x plus 1 plus y. So y is equal to, then take everything to the right hand side. Are you getting my point or what? Students, you're following, what I'm saying? Are you following what I'm saying? Students. See, suppose we have got this answer over here. Let me just show you. Somebody wants to simplify more. Just let me show you over here. See, now we got this answer is equal to x plus c. Now suppose somebody is desirous of expressing in this form the answer y is equal to fx. What you will do? X plus y plus 1 divided by 2 is equal to tan inverse of x plus c. First you will take like this. Okay, that's a very easy step. Then x plus y plus 1 is equal to 2 times tan inverse of x plus c. Then you can write y is equal to 2 times tan inverse of x plus c minus x minus 1, and that's it. Why I don't prefer to do all such things is because you can see that 1 is also constant and here c is one constant. Only thing is that in this solution c is going to be the arbitrary constant, whereas 1 is the true constant. Are you getting the point, students?
Yes, ma'am.
So 1 is 1 itself, but arbitrary constant means what? It can take any value. So c can take any value. So this way also you can present the answer.
Ma'am, this equation may be wrong, no?
Which equation may be wrong? Which equation may be wrong?
Ma'am, y equal to 2 inverse. We have to find the c value was.
You don't
Yes.
have to find the value of C. How you will find the value of C if you don't know the conditions? How you are going to find? Hmm? What I'm asking you. C is the arbitrary constant. Unless some condition is given to you for the differential equation, you will never be able to find the value of C. Got it or what? Hmm? Don't confuse yourself. Idea is clear to you.
Yes.
You have to be given some conditions, then only. So right now, no conditions will be given to you. Only general solution we are finding out. Idea is clear? Whoever has asked this question, have you got the point?
Yes, ma'am.
Yeah, so don't confuse yourself. You will just keep C as it is only. Okay, so those of you who wish, you can just note down this problem. Then we'll go to the next part. Suppose you are given some additional condition, suppose at x is equal to 0, y is equal to 1, like this way, if you are given some additional condition, then you will be able to find the value of C, otherwise not. Idea is clear to you? That is why we are telling all the time that C is the arbitrary constant. That means at this point of time, C can take any value. Okay, very good. So now we'll just go to the next part. Okay, so we have seen reducible to variable separable and variable separable itself. Now what we are going to do, we are going to see the new type, which is called Leibniz linear equation. So just write down the heading in your notebook. Leibniz linear equation. Okay, so now what is the Leibniz linear equation? It is of this form. Just see here. dy by dx plus py is equal to q. Now, very, very important thing over here. You can notice that what is the order and degree of this equation? Quickly tell me. Students, what is the order and degree?
1 and degree.
Order 1 and degree?
Degree 1.
Yeah, that's right. Where, now one more important point, where P and Q, they are either constants, okay, or they are functions of x only, okay, no other variable has to be there. So either they can be pure constants or can be functions of x. And this such a equation is called as a linear differential equation, which is specifically Leibniz linear equation. Okay. Now the important point is how to solve such equations. So for that, we are going to use
Ma'am,
one
you're not
concept.
audible.
Am I audible or what now, students?
You are audible.
Yeah, I am audible. So you can increase
Yes.
you can increase the volume of your device. At your end, you can just increase the volume of your device, okay? Or you can use the headphones. Okay, now how to solve such equations? We are going to make use of something called integrating factor. Okay, so formula for finding out the integrating factor is integration e raised to p dx. Once we find the integrating factor, what we do? We use this formula to find the solution of this differential equation. What is that formula telling us? Y into integrating factor is equal to integration of q into integrating factor dx plus c. Now, the thing over here is, okay, just 1 minute. What happened? All right, just give me 1 second. Let me just resume. Yeah. So, as I was telling you over here, first of all, we will be finding out the integrating factor. Then we will use this formula and we will find the solution to the differential equation. Now, here I told you that this is dy by dx plus py equals to q. Likewise, we can also have dx by dy, okay, plus, now you can see that when it is dy by dx plus py, that time the function is y is equal to fx. That means x is the independent variable and y is the dependent variable. But supposing it is reverse way, Supposing we have the function as, let us say, x is equal to gy. Now in this case, this is the independent variable and this is the dependent variable. So in that case, our equation will change. What will happen? It will become dx by dy plus px is equal to q. So in this case, p and q will be either constants or they will be functions of y. So can you tell me what will be the integrating factor in this case? Supposing the equation is dx by dy, what will be the integrating factor? E raised to integration p. What I should put over here?
dy.
Dy, correct. And for the solution, what we will write? X into integrating factor is equal to integration of q into whatever is the integrating factor. And over here, what we'll write? Dy plus c. So both these forms you please note it down, no? Because the question can be asked either this way or this way. So
Ma'am,
either
could
way,
you repeat again?
which part? Which part?
Formula part, ma'am.
This means this part, this formula.
Yes, ma'am.
See, what is the formula? First of all, you tell me one thing. When we are writing dy by dx like this way, this form, which is the dependent variable and which is the independent variable? This much you just tell me first. If I write like this, just tell which is dependent and which is independent variable. Quickly. Now, very easy question I've asked you. Dy by dx plus py equals to q. Which will be dependent and which will be independent? Students, such a basic question I asked you. What has happened to you?
Ma'am, in which equation? Which equation?
This, you are looking at the screen, no?
Y is dependent, X is independent.
Yeah, y
X
is
is
dependent,
independent,
x
Y
is
is
independent.
dependent.
Yeah. So now regarding somebody was asking me repeat solution. So there is nothing to repeat actually. So whatever is the dependent variable that you will take y into integrating factor, integration q into integrating factor dx plus c. Idea is clear to you? Yes or no? So in this case, the dependent variable was x. That is why we took x into integrating factor is equal to integration of q into integrating factor dy plus c. Following? Students of division 1 and 6.
Yes, ma'am.
Yes,
Yeah.
ma'am.
So you take down both the forms, then we'll see the problem based upon this Leibniz linear type. Done this part?
Yes, ma'am.
Yeah, okay. So let's see the sum based upon this Leibniz linear. So first of all, we will do one small manipulation and we will write this in our standard form. What I will do, I will divide both the sides by x plus 1. So, okay, now is this in that form? Dy by dx plus py is equal to q. Is it like that? Just see, what do you think? Is it in this form? Dy by dx plus py equals to q. Is it like that?
Yes, ma'am.
It is, isn't it? What is p? What is the value of p? 2 upon x plus 1. And what is q? 1 upon x plus 1. Okay, now what is the integrating factor formula? We already saw previously, if you have noted down. Integrating factor e raised to integration p dx. Now this is a very easy integral. You all tell me. You only tell me. What is the value? E raised to how much? Fast.
2 log 1 plus
2 log 1 plus x means I'm going to use log this thing. Log,
plus
log of
1
x plus 1 square.
square.
Now it is e raised to log. So what this will be? Only
X plus 1 square.
Right. So now we are again going to use this formula and we are going to report the solution. So y into integrating factor, so x plus 1 square is equal to integration of, I hope you have noted down the formula, q, that is 1 upon x plus 1 into integrating factor, that is x plus 1 square dx plus c. Now this will cut out. It's a very easy integral. You can just tell me like that. Just verbally, you can tell me this integral. Very easy. X plus 1 dx, integral of x plus 1.
Square upon 2 plus x.
Yes, x square upon 2 plus x plus c. Now here again, once again, if you wish to report the answer in terms of y, then you can take x plus 1 square in the denominator, but there is no need, according to me, to do all this, and you can leave the answer here, and that's it. Idea is clear to you about Leibniz linear equation, how we are going about it? Followed something what, students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so let me bring up one new
Ma'am,
problem.
let us complete.
Okay, yeah. All right, take 2 minutes time, complete this, then we'll go to the next sum. Now let's do the new type name in the same type, but we'll do the new sum. Okay, so just tell me how you are going to put this in the required form. So it's very easy. Yeah, tell me what you will do. We need to put this in the Leibniz linear equation form. What should I do? Just suggest what I should do. Very easy.
Divide by cos square x.
Yeah, divide by cos square x. See, now dividing by cos square x means 1 upon cos square means it is secant square, isn't it? Yes or no?
Yes, ma'am.
So what I will do? Here cos square x, I will just write like this, secant square x. So dividing by cos square means that is secant square x only. So like this. Now you can tell me which is P and which is Q. Which is P? Secant square x. Which is Q? This RHS, right? So what is the integrating factor in this case? E raised to integration P dx. That means secant square x dx. So what is the integration of secant square? Let me know. Yeah, what is the integration? Secant square?
Tan x.
Tan x. Now we can use the formula and solve. So y into integrating factor. So e raised to tan x is equal to integration. Now q. So secant square x into tan x into integrating factor and plus c. Now left hand side, nothing is to be done. So right hand side, what will you do? How to go about all this? Very easy. How we will go about the integration? Anybody? We have to make a substitution. For tan, you can make the substitution. So then you will get secant square x dx is equal to dt. So all this will become integration t into e raised to t dt plus c. Now this is a very, very commonly occurring integral. So y into t raised integration of t into e raised to t, many times you might have solved. So how much is it? Just like that also you should know this one, because many times you might have solved this integration by parts. So what is this equal to? E raised to t into bracket t minus 1 plus c. Okay, by integration by parts, you will get that. So in place of t, again we are going to put e raised to tan x into bracket tan x minus 1 plus c, and that's it. Now at this stage, once again, I told you, if you wish to simplify, you can transfer this e raised to tan x to the right hand side. Okay, so here I will just write in a different color. So if you transfer to the right hand side, you will get your equation like this. Tan x minus 1 plus c e raised to minus tan x. So this way also you can express the answer, or you can leave it here. Idea is clear to everybody? Yes or no? Getting something? Yeah,
Yes,
students. Okay, so you can note this. Then after that,
Last step, ma'am.
which step? Second last? Which step? Second last?
Step from bottom.
What you want to know? Yeah, tell me now.
Ma'am, from where did that t minus 1 came?
You know integration by parts, no? Something called integration by parts. Have you heard of it?
Oh, yes, ma'am. Yes, ma'am. I got it.
So we have done integration by parts and got this. Now I wrote directly because many times you might have done this. T into e raised to t, it is the most common one. Either t into e raised to t or t into e raised to minus t. These are very, very common. So directly I've written the answer, but otherwise it is my integration by parts. You can do it. Okay, you know UV rule, no? Everybody knows UV rule or what? Integration by parts rule.
Yes, ma'am.
So that rule we are applying and doing integration by parts. See, solution of the differential equation means what? It is the integral. So the basic skill which you should know is your basic calculus. That means derivative and integration. That is why in the prerequisites, you remember in the first lecture what I told you, prerequisite for this chapter is trigonometric identities and the basic rules of differentiation and integration. Once you know that, this is a breeze. That means you cannot make a mistake. Yeah, all right. So is this completed? Have you finished and completed, students? Or no?
Yes, ma'am.
Yeah, okay. All right. So we'll just now we'll go back. So this was the Leibniz linear equation form. Now, sometimes this may not happen. So similar to Leibniz linear, but one thing is different. You just observe this equation, which is here on the board, and tell me what is different between the previous one and this one. Quickly, you will be able to tell. Too much thinking is also not required. What is different?
Y raised to n.
In the right hand side, we have got this additional term y raised to n. Okay, but see, n belongs to the set of real numbers, but its value is not equal to 0. See, the meaning of all this is that belongs to real numbers excluding 0 value. See, because if it is 0, if n is 0, then again it will become the Leibniz equation only. So that much you have to just remember. So it's not equal to 0, but it is a real number. Now, if this is the type of equation that we get, what we will do, we will try to convert this to this form. Once again, P and Q, they are constants or they are functions of X, that remains the same. Also, your equation can be like this also. Bernoulli's equation, it can be also in this form. Px is equal to Qx raised to n, okay? So then you have to make the relevant changes. This way also it can be. But right now we are taking just this form. So we have to convert this to this. So how do we do it? Are you seeing the screen, students? Can you see the screen? What I'm showing you over here?
Yes, ma'am.
Yeah. So for that conversion, the first step is like this. We have to divide both the sides by y raised to n. Okay. Now for that, I will just take you to a new screen and show you all the things. See, first of all, we have our Bernoulli's equation, dy by dx plus py is equal to qy raised to n. Now I am interested in converting it to normal Leibniz linear equation so that I will be able to use the integrating factor and all that and solve. So for that, the first step is divide by y raised to n means what? Y raised to minus n dy by dx plus py, okay, divided by y raised to n means 1 minus n, it will be over here, is equal to q. This part is clear to everybody in the class? Students of division 1 and 6, is it clear to you what I did, this first step?
Yes.
Yes or no?
Yes, ma'am.
It's clear, no? Yeah, okay. So now what we will do, see the next step. Huh? Let y raised to 1 minus n be equal to v. So I'm changing the variable from y to v. Now for that, now what I have to do further changes, I have to differentiate and find out the value of dy by dx. So we are using basic derivative principles. Okay, so there should be no difficulty in this. Simply I'm differentiating both the sides and I'm getting y raised to minus n dy by dx is equal to 1 upon 1 minus n dv by dx. And now I'm going to substitute everything in this equation. So what I'll get? 1 upon 1 minus n dv by dx plus, okay. Now here we have y raised to 1 minus n is v. So pv is equal to q. And then what I'll do? I'll write this as dv by dx, okay, plus p into 1 minus n into v is equal to q into 1 minus n. And remember, n is a real number. So basically that is the constants which we are attaching to p and q. And in this way, we have converted to this form. Idea is clear how we are converting. Is it clear or what? Students, you have to answer something. Is it clear to you
Yes,
how we
ma'am.
convert
Yes.
it? First step is to divide by y raised to n. Okay, and after dividing, whatever is the coefficient of p that you're getting, for that you are going to make the substitution v. After that, you will differentiate and then you will find out this derivative dy by dx in terms of dv by dx and you will get this equation. Now I'll just go back to the original.
Can you please explain the last step?
Which step you want me to explain? Here also the same things are there. Just ask from here. The same steps are here on the slide. You can just ask me from here. Which step you want me to explain?
Ma'am, 1 upon 1 minus n dv by dx.
Where 1 upon where?
It was on the previous slide.
1 second. 1 minute. Okay. Where?
Yes, ma'am. The 1 upon 1 minus n dv by dx plus pv equal to q.
Array, this I have substituted, no, over here. We have substituted all this over here.
Okay. Yes, ma'am.
Yes or no?
Yes, ma'am. Got it.
See, this is y raised to minus n dy by dx, isn't it?
Yes, ma'am. Yes,
This
ma'am.
is
Got
this
it.
value. So this I have substituted over here. Got it or what?
Yes, ma'am.
Okay, fine. So, yes. So we are here. So now what has happened? Now we have got this equation. Now we can write the integrating factor as usual. So for this integrating factor, only thing is you remember 1 minus n also will be considered, okay, not only p. So you will write integration of 1 minus n e raised to integration 1 minus n p dx. And then again your solution also same way. So now our dependent variable is v. So v into integrating factor is equal to integration q into integrating factor plus c. And remember, whenever we are saying integrating factor, now this 1 minus n also you have to multiply. That is a very important step. So you don't have to forget it. And then you just integrate and you will get the whatever is the solution. So is this theory part clear to everybody? How we have to go about it? Bernoulli's differential equation. Anybody has any doubt? Just ask me. Anyone? Students? Anyone has any doubt? Nobody is saying anything. So how I have to understand whether you understood or not? Yeah, division 1 and division 6 students. How should I know whether you understand or not if you don't speak?
Understood, ma'am.
No doubt.
No doubt. Okay. All right. Now let's try to solve the sum. First of all, is it Bernoulli's form? Just tell me, is it Bernoulli's equation? Is it so? Just see. Yes or no?
Yes, ma'am.
Yes, it is. See, dy by dx plus I can write y upon x. Okay, so I'll remove that x. This is equal to x square y raised to 6. Now this is the Bernoulli's form. So in this case, just tell me what are p and q. What is P and what is Q in this case? Fast. Very easy question I asked you. What is P and what is Q?
P is
P is
1 by x.
1 by x. And what is Q?
Q is x square.
X square. Okay, but now this is Bernoulli's form. So we have y raised to 6. So by what we have to divide? So we have to convert it to our normal regular Leibniz form. So by what we have to divide? Just tell me. The same thing what
Y
we
raised to 6.
we have to divide by y raised to 6. Now if I divide by y raised to 6, what I will get? Just see. Y raised to minus 6 dy by dx. Okay, plus 1 by x y raised to minus 5 is equal to x square. Getting it? Now after we do this division, we have to make a substitution. So who will tell me what to substitute? Same what we did in the theory, the same thing we are doing here. So what substitution I should make? Let's see. Who is the smart student in the class? Let us see. Tell me what I should substitute with V. Let V be equal to or refer to the theory which I had shown you just now and tell me where I should substitute.
Y raised to minus 5 is equal to V.
Yes, very good. Y raised to minus 5 is equal to V. Now we have to differentiate this. So using the simple principles of derivative, this will become minus 5 y raised to minus 6 dy by dx. That will be equal to dv by dx. So what we will write? Y raised to minus 6 dy by dx is equal to minus 1 by 5 dv by dx. Okay. And now we will substitute. Where we will substitute? In this modified equation. So minus 1 by 5 dv by dx. Okay. And we will have plus v by x is equal to x square. Now what is the value of p and q? Now already we have sort of written the equation, but we will make some more changes. dv by dx. Here I will write this like this. Minus 5 by xv is equal to minus 5 x square. And now we have got in the proper form. Which form? dy by dx plus py is equal to q. Now you can just tell me. Tell me what is the value of p and what is the value of q.
P is equal to minus 5 by x.
Yes, that is correct. P is equal to minus 5 by x and q is equal to minus 5.
Minus 5x square.
Yes. Now you have to use the formula and find the value of the integrating factor. So what will be the integrating factor? Let me just write here. E raised to integration p dx. So integration minus 5 by x dx. So what is this integral value? Who will tell me? Very easy. Anybody can tell?
E raised to power minus 5 log x.
E raised to?
E raised to power minus 5 log x.
E raised to power minus 5 log x. But you know, this is equal to x raised to minus 5, no? And log will get cancelled. So finally,
Yes.
what will be left with? X raised to minus 5.
X raised to power minus 5.
Yes. And now what we can do? We can use all that to write the solution. Okay. So here I will just start writing. Hopefully you had noted down all these things. See, sometimes by chance I may proceed little fast also. Okay. So you have to tell me to stop so that I can give you time to write. Okay, integrating factor. Now dependent variable is v. So v into x raised to minus 5 is equal to integration of now q. Q is minus 5x square into integrating factor is x raised to minus 5 dx plus c. Okay, now you can tell me. This is a very, very simple integration which we are doing over here. So v into x raised to minus 5 is equal to minus 5 integration of x raised to minus 3 dx plus c. Now what is the integral value? Minus 5 x raised to, just tell me. Integration of minus 3 quickly.
-2 upon -3.
Yeah, very good. Integration of x raised to n, you know it, x raised to n plus 1 divided by n plus 1. So minus 2 divided by minus 2, right? Plus c. Okay, now in the last step, we must resubstitute the value of v. What value we had given to v? I raised to minus 5, isn't it? So I raised to minus 5, x raised to minus 5 is equal to 5 by 2 into x raised to minus 2 plus c. Now I told you, if you wish, you can simplify further also. That is up to you. Okay. So what you can do is, you can take this y raised to minus 5 in the denominator. Instead of writing in this way, you can take it as 1 upon x raised to 5, y raised to 5. This way also you can write is equal to 5 by 2 divided by x square plus c. And then after that, you can even multiply this x raised to 5 to the right hand side. If you do that, then what will happen? You will get 1 upon y raised to 5 is equal to 5 by 2 x cube plus c x raised to minus 5. Like this way also you can write your answer, and this is also correct. This is also correct. Idea is clear to everybody? Understanding something?
Yes, ma'am. Yes, ma'am.
Yes or no? Okay. All right. So I think now the class time is almost over.